Hello viewers, this is Ved. Today I'm having guys the problem number 1.5 from the SS Crow 2. This question guys, when I used to give to my students to solve this problem, what I have seen that they do a very common mistake. Okay, a very, you can say, the natural mistake that may happen by the lot of people. Okay, so what I'm going to do, first I'm going to read the question formally for you, and then I'm going to show you the mistake that the student does, and then I'm going to show you the actual solution, and we'll try to examine there are multiple ways through which we can solve this problem. Okay, so we will not just stick to a one solution. We will try to put our hands on the other methods also, that how do we solve this problem. Okay, so it's a very good video going to be. So guys, I would suggest that please watch till the end this particular problem solution. Okay, so first let me read the question guys for you. So what it is saying guys, that the two bodies move in a straight line towards each other at initial velocities v1 and v2. So guys, let me make the figure first. So guys, suppose if we have this is your what we can say, one object is here and one object is here. This is, let's say, call 1, and this is guys, let's say, call 2. This is guys having velocity how much, v1, and this is having velocity what, v2, with constant acceleration a1 and a2 directed against the corresponding velocities at the initial instant. Means guys, their accelerations are what, it is a1 in this direction and a2 in this direction. Okay, and of course after that guys, it is saying that what must be the maximum initial separation L max between the bodies for which they meet during the motion. Okay, for which they meet during the motion. So guys, what happens, I'll show you first I'll show you the wrong way of solving this question, and then I'll show you the right way also. So guys, if you see, this is, let's say, the L max. Okay, this is the L max that may exist, at which guys what, they should be like there, if we want that at the end they should meet. Okay, if it is less than Lmax, of course they are going to meet, but if it is more than Lmax, there is no chance that they are going to meet. So the student does what guys, see, they do like this way, and maybe if you also attempt this problem guys, you might also do the same mistake. Okay, so if you want, you can pause the video right now only, and you can try from your side, and when you will come back, and I'm going to show you the you can say the method that student does, and maybe you will also see that you have done the same thing only. So guys, here if you see what they do, they say like this, that sir, see, the thing is, this particle will go some distance maybe, and let's say it will take how much distance it will cover. Let's say its velocity will become 0 somewhere here, and it will come also, and it will also meet, and this will travel some distance, and its velocity also will become 0. So this distance s1 and this s2. So guys, so L max should be equal to what, s1 plus s2. Means what they were saying, they says like this guys, that this is going and velocity is going 0 0 0 0 0, and it will become 0 here. Okay, and so it rests here, and this will come, and guys, it will also lose the velocity, and it will reach here, and its velocity also becomes 0 at this moment, let's say. So this s1 and s2 is what guys, is your the distance that they have traveled before their velocity becomes 0. So if I add s1 plus s2, so that will be what guys, L max. Okay, so if you see guys, in this case, the answer that the student reports, they say like this, that L max should be equal to what, s1 plus s2. So of course guys, if you see, s1 will be how much, if I just write in this separately guys, so v1 square minus 2a s1 is equal to what guys, is equal to 0, because final velocity is going to be what guys, 0. So s1 is equal to what, v1 square by 2a1. Similarly guys, s2 is equal to what, v2 square divided by 2a2. So if you see, if I sum both of them guys, so answer will be what, v1 square divided by 2a1 and v2 square divided by 2a2. So guys, this way they show me this solution guys, and of course this answer is what guys, wrong. Okay, this solution is guys what, this is wrong. This is not a right way to approach this problem. Okay, this is not a right way to approach this problem. So now you might ask, sir, what is the issue in this method? Okay, what is the problem with this? Okay, so guys, if you see this answer would be okay if let's say we allow that the body, when it reaches to velocity 0, it should come at rest. Okay, it should come at rest, it should not go back, because they haven't said that the acceleration is going to be what guys, stopped anywhere in the question. Like if your velocity is going to be 0, the acceleration is going to stop. This has not been said in the question at anywhere. Okay, so it means guys, what is the chance that let's say it might take t1 time, this might take guys what, t2 time. So what happened, it's not necessarily that they both will come at the same time and meet. If that was happening, then that could be the case. Okay, that could be the L max. Okay, but guys, here because the velocities and accelerations are different, so there is a possibility that its velocity becomes 0 earlier, and it is still what guys, it is coming. So what may happen, that it velocity now returns back. Okay, it returns back and it is coming. So guys, of course, then L max will be what, needed more. So that's why guys, we can't use this technique. Okay, we can't use this technique. I hope you're getting my point guys. What I'm trying to say again, I'm just repeating guys. Suppose this particle is coming, and guys, its velocity becomes 0 here. Okay, and now your particle is here only. So now it is going to what, it is going to go back, and let's say it is coming and it is slowing down. So if this is the case guys, they are might not meet. Okay, if this is the case guys, that this comes and its velocity becomes 0 and it's stopped here, it is not going to return back, then the of course the L max answer would be what guys, this only. Why? Because it came and it got rest, and this will come and it will also get rest. Then this is the what, simply L max. Okay, that S1 plus S2. But if this is not the case, because they had to meet at the same time, then this is the necessary condition guys. Because acceleration is continuously acting, we can't say that this would be the solution. Okay, why? Because the first one will stop early and maybe the second one stop later. Okay, so for that time period the problem will come. So I hope what I am trying to convey, you are getting my point. So if you have understood this idea guys, what I would advise, there is three ways of course to solve this problem. Okay, the first way is guys, always remember, when the two particles you see and some sort of kinematics is getting involved, I would advise that you go with the what, the relative velocity or the relative velocity kinematics. Okay, so you use that technique, you can solve this problem very easily. The second way is, if you don't want to use the relative velocity method guys, then you have to use what, the idea of maxima minima, and then you can solve this problem. And the third of course is what guys, maybe we can pull off this question with the graph also. Okay, so what I'm going to do, I'm going to show you all these possible three methods. Okay, if my time will allow. So let's see guys, let's see the first method. Okay, so if you see guys, what I'll do, I'll make this body guys, let's say I'll make this body 1 to be at rest. Okay, I'll make this body to be at rest. So guys, the velocity of 2 with respect to 1 will be what guys, it will be v2 minus v1 vector. So guys, it will be simply what, it will be v2 plus v1 vector, which is what, towards a. Okay, so it will be what guys, simply v2 plus v1. Okay, v2 plus v1 towards a, of course guys, towards a. Okay, that is what guys, v21. And if you see guys, the acceleration of 2 with respect to 1 guys, that is going to be what, a2 minus a1. So guys, it will be what, it will be a2 plus a1 opposite to a, of course guys. Okay, opposite to a means it is going to be resultant guys, what means, if I make this as a rest guys, okay, if I make this as a rest, so what I'm going to see, that this particle is going to move with the velocity of what, v2 plus v1 in this direction. and guys the relative acceleration that you are going to experience is what, a1 plus a2 in this direction. Okay, so if this is the case guys, what is going to happen now? If you see, what could be the L max guys? If you see, now if you see, this particle will go guys and velocity will become what, slow 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 slow. So at the end guys, it should just reach here. Okay, so the velocity should be what guys, 0. Okay, so when it will reach to guys what, point 1, the particle 2 guys related to 1, if we are seeing, it should just reach guys what, to the point 1, and its velocity must be what guys, 0 at this moment. So if this is the case getting followed guys, then that would be what, the maximum distance that they should have to get meet. Okay, to if they had to meet guys, so this is the condition that this should move and lose the velocity, and at the end guys, it should just what, reach to the point 1. So if this is the case guys, then we will say that that would be what guys, the L max. Okay, so if you see, in this case guys, we can simply say that the L max, guys, if we want to calculate, we can say v2 1 square, okay, is equal to u2 1 square plus 2a21 into what guys, L max. Okay, simply I am writing like this. So guys, if you see, v21 square should be what, 0, because when it will reach at the point 1, so the velocity will be what guys, going to be 0. u21 is nothing but guys what, that is v2 plus v1. So what we can write here, this is v2 plus v1 whole square, and guys retardation is happening, so minus 2 a1 or a2, if you want to write a2 plus a1 L max. So guys, what we get, we get L max is equal to, v2 plus v1 whole square divided by 2 a2 plus a1 guys. So that would be what guys, your L max answer. So if you see, we got the answer guys in this case. Okay, now uh, let me add guys few pages here. Okay, I'll add few pages. 1 minute guys. Okay, okay, so guys, if you see, this is the answer that you are going to have. That is what, L max is equal to what, v2 plus v1 square divided by what, 2 into what, a2 plus a1. So this is the guys what, this is a technique that I would advise you to approach. Okay, this is the technique that I would advise you to approach to solve this problem. But let's say if you are interested that sir, I want to solve this problem with like taking the individual particles analysis, and then we want to solve this problem. So guys, let's take that method also. Okay, method 2. Okay, method 2 I am going to give you for. Okay, so if you see guys, what I'm going to do, the thing is, suppose guys, there are these two particles are there. Okay, so what I'm going to do, if you see guys, this is, let's say this is the L distance that we should allow. Okay, let me make a different figure only is here. Suppose guys, this is your two particles, and guys, this is what, this is particle 1 and this is what, particle 2, and this is what guys, this is your L. Okay, this is your L. So guys, if we want that L should be what, maximum, so that they can meet. Okay, that is our interest, and of course it should happen at a common time. It should happen at a what guys, common time. So we want L should be what guys, maximum. So if you see, what I'm going to do is, this velocity is what, let's say v1, and this is what guys, a1, this is given to us, this is what guys, v2, and this is what guys, a2. So if you see guys, the the meeting guys, the relative distance between them, that should decrease guys. Okay, that should decrease. So if you see, what I'm going to do, I'm going to do like this that in t time, the particle 1, the particle 1 will travel, will travel x1 distance, let's say. Okay, will travel how much guys, x1 distance. or displacement, whatever you want to write. Okay, so the displacement guys, okay, travel will have position x1 guys. Okay, so I'm calling this as a what guys, origin only. Okay, let's take this as a origin only. Okay, so it will have guys what, the position is what, the position is going to be what guys, x1. Okay, so at the particle one guys, where it is right now at located, I'm taking that position as a what guys, origin. So guys, what we can say, we can say that at in t time guys, how much it will travel. So x1 will be what guys, simply v1 into t plus half minus a1 into what guys, t square. That is the first thing. Now for x2 guys, okay, what would be the position of this particle? So this particle will have the position guys, simply what we can say, it is, let's say if it is covering this distance guys, so what we can say, we can say it will be, this is L guys, this is L. Okay, this is L. So x2 will be, x2 will be what guys, x2 will be, let me remove this, let me remove this case. Okay, so guys, it will travel how much, this much. Okay, so its position will be simply guys what, L, L minus what, this whatever it has traveled. Okay, that would be what, the position of this particle. I hope this is okay. So guys, so what I'm going to do, x2 will be the position of the second particle guys, it is going to be v2 into t. Okay, v2 into t. Of course guys, its direction will be what, opposite. Okay, so let's put minus v2 into t plus half a2 into what guys, t square. Directions, I'm taking opposite guys, so that is what, 1 minute guys, I think here I have to write position of this particle from the origin. So this will be guys what, L minus or okay, uh, x2 I have to write now. So guys, x2 will be L minus v2 into t minus half a1, sorry, a2 into t square guys. Okay, I hope this is okay guys. x2 you have understood. So this is L guys, this is L, this is L, and this is that it is going to travel. Okay, this part it is going to travel. So its position from the origin will be what guys, L minus v2t minus half a2 t square. I hope this is okay guys. Okay, so now if you see guys, from these two equations, what we can say, we can say that if guys what, if they had to meet, if they had to meet, it means what, that x1 should be equal to what, x2. Okay, that is the condition. If they had to meet guys, then x1 should be equal to what, x2, whenever they are going to meet. So if they have to meet, they have to meet, then x1 should be equal to what guys, x2 at t equal to t, whenever it is going to happen guys. Okay, so let's equate both of them. So guys, it will become v1t minus half a1t square is equal to what guys, L minus v2t minus half a2t square. Okay guys, so let's do guys a little bit separation here and there. So guys, what we will have, we will have v1 plus v2 into t, and then guys, this is going to be what, minus, okay, minus plus guys, and this will go this side minus. So half a1 plus a2 into t square is equal to what guys, L. Okay, so if I want to maximize L guys, okay, so L should be maximum guys, L max I want. Okay, I want. So guys, what I will do, I will do dl by dt should be equal to what, 0. Maximum minimum we will apply guys. Okay, so if we will apply this, what we will get, so if you guys differentiate this function, what we will have, v1 plus v2 minus guys, 2 gets cancelled, so a1 plus a2, a1 plus a2 into t is equal to what guys, 0, dl by dt should be equal to 0. So t is equal to what, guys? It is simply v1 plus v2 divided by a1 plus a2. So at this moment they should meet, guys. Okay, at this moment they should meet, and then we will have what, guys? L maxima. So let's put this value, guys, in the L function. Okay, so L max should be what, guys? If you see, what I'll do like this, guys, that if I put this function, it will become, sorry guys, it will become v1 plus v2 whole square divided by a1 plus a2 minus, guys, it will become what? It will become half of v1 plus v2 square divided by a1 plus a2. So guys, if we solve this, what we will get? v1 plus v2 whole square divided by 2 of a1 plus a2. So guys, that is also what? The answer. So if you see, guys, with both the ways I have solved this problem for you. Okay, of course with the graph also we can solve this problem. So it is your job, guys. You solve this question with the graph. Okay, if you can do, and let me know if you have done it that. Okay, maybe in some other lecture I will cover the graph method also for you guys. Okay, so I hope you understood. I'll see you guys in the next lecture where I will cover this problem 1.6. Okay, so thank you, guys.